Hello students, welcome. So today we are going to learn about line following robot and with the help of IR sensor. So basically you have heard a lot about line follow robots which is made by the IR sensor. So here we are going to understand how IR sensor works, the working of IR sensor principles and different types of IR sensors. Okay. And if you have seen IR sensor, there are two LEDs. What are that two LEDs? We are going to understand that also. So each and everything about IR sensor will be explained in this video. So let's get started with today's video. So today we are going to get an overall view of IR sensor, like how IR sensor works, different perspectives of IR sensor, how we work with IR sensor, how potentiometer works, how the pinout works. Everything will be explained. So let's get started without wasting any more time. So what is an IR sensor? IR sensor is an electronic device that emits the light in order to sense some objects of the surrounding. An IR sensor can measure the heat of an object as well as detects the motion, usually in the infrared spectrum. All objects radiate some form of thermal radiation. We all know. We have already studied the PIR sensor. In the PIR sensor, we got to know that all types of sensors sense different types of energy. Okay, some might sense the light, some might sense the distance, some might sense the with the help of wavelengths, with the help of waves, some might sense with the thermal energy, and the IR sensor measures with the help of heat. Okay, objects usually. Okay, deduct. So usually in an infrared spectrum, all the objects radiate some form of thermal radiation. It's somewhere same around the PIR sensor, okay, passive infrared sensor. These types of radiations are invisible to our ears, our eyes, but infrared sensors can detect this kind of radiations. The emitter is simply an IR LED, okay, light emitting diode, and the detector is simply an IR photodiode. Photodiode is sensitive to the IR light of the same wavelength which is emitted by the IR LED. When the IR light falls upon the photodiode, the resistance and out the voltage will change the proportion of the magnitude of the IR light received. So basically, if you have seen the IR sensor, there are two things which is IR LED and IR photodiode. So this black one is photodiode. This is a receiver for us. Okay, this LED emits a light. Okay, this LED is emits light, which is infrared light, which is not visible to our eyes. Okay, that has some wavelength which is not visible to our eyes, but that wavelength can be detected by this infrared like IR photodiode. Okay, whenever this IR light emits the light and received by this photodiode, then these particular things change the signal and magnitude of the energy, means it generates an electric signal which is passed on to our microcontroller. There are five basic elements used in a typical infrared detection systems: an infrared source or transmission medium, optical components, infrared detectors or receivers, signal processing, infrared lasers, infrared LEDs of specific wavelength used as sources. The three main types of media used for infrared transmissions are vacuum, right? We know it travels to vacuum, atmosphere, and optical fiber. Optical components are used to focus the infrared lights or limits the spectrum response. That is, I think so, it's self-explanatory. And let's understand the types of sensors. Okay, there are two types of IR sensors available in the market, and they are active infrared sensors and passive infrared sensor. So passive we have already studied, which is PIR sensor, which we covered already, and we developed a project also with that. I hope you remember the security systems we created with that. And now we are learning the active infrared sensors. Active infrared sensors consist of two elements: infrared source and infrared detector. Okay, infrared source includes the LED or infrared laser diode. Infrared detector includes photodiode or phototransistors. The energy emitted by the infrared sources is reflected by an object and falls on the infrared detector. Okay, so basically now you have work, or like you need to tell me in these two which is infrared source and which is infrared receiver, or what is, which if this is infrared receiver, or this is infrared receiver. Okay, so you need to tell me which one is source and which one is receiver. Okay, then let's understand about passive infrared sensors, how passive infrared sensor works. Passive infrared sensors are basically infrared detectors. Passive infrared sensors do not use any infrared source and detector. They are of two types, quantum and thermal. Thermal sensors are used infrared energy as a source of heat. Thermocouples, bioelectric detectors, bolometers are common types of thermal detectors. Quantum types of infrared sensors offer high detection performance. It is faster than thermal type infrared sensors. The photosensitivity of quantum type of detector is wavelength dependent. So basically, uh, there are two types of infrared sensors, okay, which is active and passive. And in passive, there are two types, which is quantum and thermal. So thermal sensors detects the energy or heat, and quantum deducts the what we can say wavelength. Okay, so now you can tell me which one is PIR sensor. PIR sensor is thermal or quantum. It's upon you. You need to tell me the answer. It's thermal or quantum. Okay, so let's move ahead. IR sensor working principle. There are different types of infrared transmitters depending upon the wavelength, output power, and the response time. An IR sensor consists of IR LED and IR photodiode. Together they called as photocouplers or optocouplers. Okay, so this is the working principle. Now let's understand what is IR transmitter and or IR LED. Okay, so for IR LED, which one is white one? You have seen the white LED is known as IR transmitter or IR LED. Infrared transmitter is a light emitting diode LED which emits infrared radiation called as IR LEDs. Even though an IR LED looks like a normal LED, the radiation emitted by it is invisible to the human eye. Now you can see this image and you will think that okay, it's a normal LED only. Okay, it's not so much different from the normal LED we use for lighting or different purposes. But the light emitted by this LED, okay, the light emitted by this LED cannot be visible to our eyes. It's not visible to our eyes. Okay, so I hope it's clear. And let's move ahead. Okay. Now IR receiver or photodiodes. Infrared receiver or infrared sensor detects the radiation from an IR transmitter. IR receiver comes in the form of photodiodes and transistors. Infrared photodiodes are different from normal photodiodes as they detect only infrared radiation. So please mind this. The receiver we use, which is IR photodiode, only detects the infrared radiation. They are not same as other photodiodes. Below image shows the picture of IR receiver or photodiode. Different types of IR receiver exist based upon their wavelength or what wavelength they can detect, then according to their voltage and packages. When used in a IR transmitter receiver combination, the wavelength of receiver should match with that of transmitter. Okay, the wavelength of receiver should match the that of transmitter. That it's very important. If it doesn't match, it will not detect. Okay, sometimes some if you have seen or used the IR sensor before also, then you might have seen that sometimes our IR sensor don't work. So the main reason of this should be the LEDs, the IR LED and IR receivers wavelength are not matching with each other. Okay, this issue mostly comes with the new, or like if you buy purchase some new IR receiver or IR like IR sensor and you face this issue. So the solution of this issue is that the wavelength is not matching. That's why this is happening. Okay, the emitter is an IR LED and the detector is IR photodiode. The IR photodiode is sensitive to the IR light emitted by a IR LED. The photodiode's resistance and output voltage changes in the proportion the IR LED receives. This is underlying working principle of the IR sensor. Let's understand this principle. Let's understand this principle with the help of the complete according to this diagram. So basically, you can see this is my IR sensor. Okay, this is my LED number one, which is IR LED. This is my second, which is photodiode. Okay, IR photodiode. So this LED will emit a light which is not visible to our eye. Okay, and it will go, and when object is detected, then the light will reflected back and will be received by this photodiode. Okay, so you can see the principle, like the working principle of this two, like this LED, this IR sensor matches with two sensors. Name them. Yes, if you name them as ultrasonic sensor and PIR sensor, you are absolutely right. Okay, the working of this somehow matches with the ultrasonic sensor, because ultrasonic sensor also sends the waves and receives the waves, whereas the PIR sensor also sends the what you can say waves, or you can say heat. Okay, and reflects that back. So this is how the IR sensor also works. It emits LED light, which is infrared lights, which is not visible to us, and then once the object get reflected by that, it will catch that, or by the photodiode. Okay, so this is the working of the complete, what we can say, LED or IR sensor. Okay, I hope you understood the working of IR LED and photodiodes. Okay, IR photodiodes or IR receiver and transmitter. I hope you understood that terminology also. So now let us begin with our first project, which is we are going to create a line following robot. Okay, so this is like one of the beginners, or we can say one of the most created projects whenever you begin with the robotics or embedded systems. So this is our line. We are going to create a line following robot. Okay, so I'm gonna show you the stimulation part of this. Okay, I'm gonna show you the stimulation part of this, but I highly recommend you to do it physically by creating such lines and making this kind of robot. Okay, so those who all don't know how we make this kind of robots, so let me explain you. So basically we don't use four motors here, we only use two motors. Okay, one motor and two motor, and this one is normal wheels, and this board is known as chassis. Okay, you can buy this chassis from market. It's not very expensive, not more than 150 rupees. Okay, you can buy this chassis from the market. Lots of different types of chassis are available, or you can buy online kit also. So yeah, you need to try this kind of robots at your home, because in upcoming videos we are going to make lots of robotic cars and different types of projects with the help of robots. So basically you need chassis a lot in the future videos, so I do recommend you to buy one. Okay, so let's go ahead. So first one is Arduino Uno. What we require, component list are, we require Arduino Uno, we require L293D motor driver IC. So there is a this kind of motor driver is here. Okay, it looks like this. Okay, it looks like this. Here you can see that. Okay, but in the virtual simulation, the L293D motor driver looks something different, so don't get confused. L293 motor driver looks something different in real life, but in online simulation it looks different. Okay, then we require geared motor, two geared motor. Then we require IR sensor modules two. Okay, and then we require connecting wires. Okay, we require connecting wires, which is jumper wires, and then we require power supply, which is our battery, and at the end of that, battery connector. Okay, so there is a Arduino Uno's battery connector also, which I have already explained in the previous video what a battery connector looks like. Okay, so I hope these are the basic components you are familiar with, and so let's get started with circuit diagram. So you can see the circuit diagram out here. We have connected our battery also. Okay, why we connected the battery? Because we do need to provide them the power, right? We need to provide them the power, which is 5 volts, and we only have one 5 volts, so one 5 volts goes here, that's why. Okay, so this is the battery connection out here. Okay, I hope it is clear to you, and then let's get started making the complete circuit diagram also. We are going to make this complete circuit diagram for you. I'm gonna make this for you. Okay, and then we come to the next part, which is coding part. So here you can see, first what we have done, we have just floated our integer values. Okay, or we can say we have defined it. Then what we have done, we have told our computer which is input and which is output, and after that we are going to do void loop. So here we started with the void loop. In this void loop we told our computer that how we are going to take the inputs, like we have read from the digital pins, and then according to that, according to our response by 0 or 1, we made our computer, we have make our robot go ahead, back, turn according to the line. Okay, so how this works, I'm going to tell you. We are going to develop complete logic for this. Do not worry. So before wasting any more times, let's get started with our Tinkercad, and let's create our first circuit. Okay, let's get our first circuit here. Just go to here, search for Tinkercad. Go to here. Okay, then after that, what we are going to do is that we will be creating a particular design, and in the design I'm gonna create circuits. Okay, so here you can see we are upon our Tinkercad platform. This is our working platform. So let's take some components. Okay, let's take some components. Let me take first. I need to take Arduino. So let's take Arduino Uno. Arduino Uno R3 is here. Let me take it here. Okay, let's reduce some size of it because we need to take lots of components, right? So let's reduce the size and keep it aside over here. Okay, and then we require a breadboard. So let's take a breadboard. Okay, so I'll take a small breadboard small, and we'll put it here. Okay, yes. Okay, it's here. Yeah. Then we will require L29. Okay, L293D. Okay, or you can call it as H bridge motor driver. You can also call it HD motor driver. Then we require IR sensor. IR sensor. Yes, we got the IR sensor here. So we require two IR sensors. So let's take two IR sensors, and then we require our gear motor. Okay, so let's take the gear motor here. Okay, motor is here. Yes, gear motor are here. Hobby gear motors are here. Okay, let's take this here, and let's take this also here. Okay, and let's close this. Okay, and now let's begin creating the circuits. So before this, let's arrange them accordingly. So these are the components you will require to create the project or the circuit. Okay, so let's create this circuit. Okay, so I'm gonna place this first one. Okay, I'm gonna place this one here. Okay, let's do it half and half. Okay, yes. So I have already placed the motor driver. Okay, I have placed the motor driver now, and then let's uh, keep our IR sensors here. Yes, yeah, and then let's again keep this our IR sensors. Yeah, yes. Okay, so we have placed our both the IR sensors, and you need to place the IR sensor in this way. Okay, in this way you need to keep the IR sensor in this way. Okay, and okay, yeah, and let's keep the motor ready. So this motor need to be shifted. Okay, so let me change this. Okay, okay, yes, yes, and now I'm gonna keep it here for now, and then what I need to do is that I need to change this one also, right? So let me change this one. Okay, yes, and yeah, this one should be here, or wait, okay, okay, and let's take it a little bit of down here, or yes, and let's take it a little bit of their side. Okay, perfect. So most of the things are done here. We have arranged our sensors properly and our components properly. Let's start doing the connections. So first thing I'm gonna do here is that I'm gonna join my positive negative of both sides so that I can get lots of positive and negative pins. So I'm gonna do like this to the positive one and change the color to red, and then I'm gonna take this one, black one, to this one and change the color to black. Okay, after that once I got it, we also need a battery, right? Because for giving the positive and negative connection. So let's take one battery also here. Okay, I got the battery, and let's move it. Before that, let me close this one. Okay, and then let's move this from here. Okay, it is moved. Okay, now this is the positive one, so I'm going to attach my positive one to this line because I need to make this complete line positive, and once I make this complete line positive, I connect this pin to this line, so this line will also get completely positive 5 volts line. So let's go and do that, but I have to click on negative, so I will connect negative to GND. Okay, so negative pins are connected through GND. Okay, let's arrange it properly because we want our circuit to look good, right? Okay, and it's black. Okay, fine. And then let's connect this positive one to here, this positive line. Change the color to red for our identifications. Okay, and yes, I hope it looks good. Okay, so we are given the positive connections right now, and then what we will start with connecting our pins. Okay, which kind of pins we need to connect first? So we need to connect the positive pins of the IR sensor. Okay, so you can see this is the power pin. Okay, power pin means VCC. Okay, power pin means VCC 5 volts is required. So how we are going to provide the VCC to this? Okay, so we are going to provide VCC to this by clicking from here and taking this to VCC out here, 5 volts of VCC here. So let's make some changes or arrange them properly. So now we are just connecting the power pins. Okay, because first we are just concentrating or connecting the powers so that our complete circuit gets powered on. And then as you can notice here, we only have one VCC pin, one 5 volts pin, which is connected to sensor, but we have two sensors. So how we are going to do that? We are going to simply do that in this way. Yeah, now these two sensors are getting power 5 volts. Okay, now these two requires 5 volts power, but before that we need to do one thing, and yes, you guessed that right. We need to connect what we need to connect. We need to connect our out, which is GND. We need to connect our GND also. So how we are going to connect GND? So this is our GND pin, and GND will be connected over here. Okay, this is also our GND. So let's connect the GND also again. Let's connect this GND to here. Okay, so you can just okay, yeah. So yeah, we can see our GND is connected. But if you observe, 5 volts is available in this line and in this line, but GND is not available. Okay, we haven't connected any GND with the help of it to the Arduino. So we need to connect one GND also, right? So let's connect this GND over here so that this complete line becomes GND, and this line will also become ground. Okay, so let's do that, and let's first arrange the pins properly. And yes, okay. Well, let's change the color to black, and this color should be also black, right? Because they are the negatives. Okay, so let me change the black color, and this color should be also black. Okay, so now positive pins of our IR sensor is done. The negative pin of our IR sensors are done. Okay, so now it's time for us to connect the motor pins, right? We need to connect the motor pins also. So how we are gonna connect the motor pins? So in the motor pins, we are gonna connect with the help of we are not directly going to connect this motor to here and this negative pin to GND. No, we are going to connect that with the help of motor driver, because we need motor driver to control these two motors. Okay, so how do we do that? But to do that things, we need to first make sure that our this is ready, our L293D is ready. So let's first connect our L239D. So I have zoomed how I am making the connection, so you can see what connections I am making. Okay, so this first, this is you can see 3 and 4 is power pin. So let's connect these power pins out here, okay, to this. Okay, so to do that, let me should do something which is called as, this is how we are gonna do it. This is how we are gonna do it. Okay, and it's power pin, so I need to make it red. Okay, and the same thing we need to do here also. It's also power pin. Okay, so let's do this also. Okay, and let's do this over here, and then over there, and then over here. Okay. So okay, so this is clear. Okay, this much is clear. Then connect the negative. Okay, so this sorry, not negative. Yes, this two should be negative. Okay, you can see ground and ground, ground and ground. Connect these two. Okay, and after that, what we need to do? We need to change the color, right? Because they are negative. They are negative. So change the colors. And please mind, we haven't connected any digital pins till now. Okay, we haven't connected any like input output pins till now. We are just making the power connections till now. Okay, so next thing we need to do is that we have connected with each other, but we haven't provided them the actual power. We haven't provided them the actual power till now. So let's do that. So here you can see we have the 5 volts. So let's give them the 5 volts out there, right? Let's give them the 5 volts out there, which is this. Okay, and let's give this also 5 volts, which is okay. Let's me change the color to red, and this is also, it also require 5 volts. So let's give this 5 volts to here. Okay, okay, and now what we need to do is that we need to give GND. So here GND is available, so let's give this GND over here. Okay, and let me change the color to black, and let's give one GND from this side. So we have given the GND also. Okay, so now the power pins are done. Okay, the power pins are done. Okay, so now let's connect our positive and negative also. Okay, let's connect our positive and negative also. So let me do some, let me zoom out. Okay, okay, yes, so you have zoom out. Okay, and now I'm gonna do is that let me move this little bit of backside. Yes, the first is negative one, so I'm going to connect this negative pin over here. Okay, over here. Okay, this is how we connect the negative pin, and let me move a little bit forward or 90-degree. Okay, yes, okay, negative is connected, and the motor's positive, let's connect it to this side. Okay, you can see input 1, input output 3, input 3. Okay, so we are going to connect something here. Okay, so let's make it red. Let's make it red. So now we have connected our motor numbers 1's positive and motor number 2's positive pins out there. Okay, now let's connect the negative of motor number 2. So I'm going to connect the negative towards this side, and so let's make connect it to here. Okay, it's positive and it's negative, right? Let's connect it over here and change it to negative, black one, and the 5 volts sorry, the positive one will be connected to this side. Okay, and let me change the color to red. Okay, so now the complete power pins connection is done. The power pin connections were quite complex, but we have done it. Okay, now what we are going to do is that we are going to connect the digital pins and the basically input and output pins. Okay, so first we are going to connect our IR sensors. Okay, so let me connect this first IR sensor to pin number, I think so 5. Let's connect it on 5 here. Okay, so how we are going to do that? We are going to click here and then connect on 5 number. But as you know, we are going to make our circuit looks good. So first of all, let me change the color to yellow, and then like this. Okay, 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 okay. Okay. Yeah. So basically, we have connected our first sensors, but let me change it to something from here also that we can see properly. Okay. Sensor number one is connected. IR sensor number one is connected on 5 number pin, and let's connect the pin number two. IR sensor pin out number this one. From here, I'm gonna take this to pin number 6. Okay, but let me change the color to green, and then let's do the same with what we done right now. Okay, okay. Just need to double tap the pin, and so it will give you one more fold. Okay, and let's take it here. Okay, a little bit ahead, and then we'll double tap here. And yes, we did it. Checked. Yeah, yes. So our both the IR sensors are connected. Okay, our both the IR sensors are connected right now. And now what I'm gonna do is that I'm going to connect my this pins. Okay, my L293D motor driver. I'm going to connect that. So this motor driver will be connected like the first, what we can say, this one. Okay, the first input I will be connecting this to pin number like around let's connect it upon 4 number pin. So I'm going to connect it upon 4 number pin, and let me change the color to this light blue, and like this it should be like this, and it should be like this, and yes, yeah, proper connection should be there. Okay, yes, and then I'm going to connect my output number 2. Okay, I'm going to connect my output number 2, which is like this one. Input number 2. Okay, it's input number 2. Okay, let's connect it to from here. I'm going to take it. I'll connect it to pin number 7. Okay, let me connect it to pin number 7. 7 is here. Let me change the color to purple, and this one, and at the end I'm going to do like something like this. Let me do like this. Okay. Basically, okay, but we can't able to see the first connection, so let me take it little bit of down that you can see the first connection also, and we're just going to do like something like this. Yes, that you can see the first connection and second connection both. Okay, so now we will connect our outputs also. So let's do that. Which is our input number 4. I'm going to connect upon the pin number 1. Okay, on the input I'm going to give this input to pin number 1, which is our IR also. Okay, it's connected. No, it's not connected. Wait, from here I'm going to press and connect upon the D1. and then from here I'm going to change the color to pink, and just I will press this here, and then we'll press this here. Okay, and then we have our last pin connection, which is this one, and this will I'll connect upon pin number 0 directly. Okay, and this one I'll connect on 0, which, and then let me change the color to brown, and yes, I hope so this is understandable. So finally you can see our complete circuit is ready. So we have developed the complete circuit of our project. So that's all about this video. I'll see you in the next video. We will do the coding part of this circuit. Okay, thanks for watching guys. Thank you very much.